Welcome to MRL. In this learning session, we'll be learning about cubic polynomial. Rather, this is also the third part of the study of polynomials. Now, what is a cubic polynomial? A polynomial of third degree is called a cubic polynomial. For example, p of x is equal to x cube plus 3x squared plus 2x plus 7 is a cubic polynomial because it is a polynomial of third degree. Now, the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, and here x is the variable, a is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x, and d is a constant. Now, the next important point of discussion is the zeros of a cubic polynomial. A cubic polynomial is a third degree polynomial, and therefore it can have at the most 3 zeros. It can also have no zeros, 1 zero or 2 zeros. Remember that. Now, the next important discussion is the relation between zeros and the coefficients of a cubic polynomial. Now, ax cube plus bx square plus cx plus d is a cubic polynomial. Alpha, beta and gamma are the 3 zeros. Then the sum of the zeros, that is alpha plus beta plus gamma, is equal to minus b by a. Or also we can say sum of zeros is equal to minus coefficient of x square, because b is coefficient of x square, coefficient of x cube because a is coefficient of x cube. That is what is the sum of zeros. So therefore remember, alpha plus beta plus gamma is minus b by a, or the sum of zeros is equal to minus times coefficient of x square upon coefficient of x cube. Now, if you take the product of the zeros, that is alpha beta plus beta gamma plus gamma alpha, then it is c by a. Therefore, the sum of the product of two zeros taken in an order is equal to coefficient of x, because c is coefficient of x, divided by coefficient of x cube. Remember that. And the product of the zeros, alpha beta gamma, is equal to minus d by a. That is, product of zeros is minus times constant upon coefficient of x cube. So try to remember these relations. Alpha plus beta plus gamma is minus b by a. Remember, it is minus sign. And alpha beta plus beta gamma plus gamma alpha is equal to c by a. It is no more minus, it is plus sign here. Alpha beta gamma is minus d by a, and that is with again a minus sign. So these three important relations of the zeros of a cubic polynomial has to be remembered. The next important point is the graphs of a cubic polynomial and the geometrical meaning of zeros of a cubic polynomial. If ax cube plus bx square plus cx plus d is a cubic polynomial, alpha, beta and gamma are its zeros. The graphs of a cubic polynomial are complex graphs. We have different cases to consider, as the polynomial can have at the most 3 zeros, it can have no zero or 1 zero or 2 zeros. Now, the different cases possible are: case 1, when the graph can have 3 zeros. The graph of a cubic polynomial can intersect the x-axis at 3 distinct points here. It has intersected the x-axis at point P, Q and R. Therefore, P alpha 0, Q beta 0 and R gamma 0 are the points where the graph has cut. It has got alpha, beta and gamma as the zeros. Therefore, remember, the first possible case is when the graph cuts the x-axis at 3 distinct points. Then we also can have a graph where it can cut in only 2 points, that is P and Q. P alpha 0 and Q beta 0 are the points where the graph cuts. Alpha is the x coordinate of point P, beta is the x coordinate of point Q, and therefore alpha and beta are the zeros of the cubic polynomial. Therefore, remember, the graph of a cubic polynomial may cut x-axis at 2 distinct points. The x coordinates of these points are the zeros of the polynomial. And also in case number 3, the graph of cubic polynomial may cut x-axis at exactly 1 point. The x coordinate of this point, that is P alpha, that is x coordinate is alpha, that is the zero of the polynomial. And the case number 4 is the graph of a cubic polynomial may not cut the x-axis at all. Then the polynomial has no zero. Remember that. Now, method of forming a cubic polynomial when the 3 zeros are given. If we are given alpha, beta and gamma as the 3 zeros, then the required cubic polynomial is x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. So this is the general relation by which we can write the cubic polynomial given the 3 zeros alpha, beta and gamma. So substitute the values of alpha, beta and gamma in this relation, we will get the cubic polynomial. Now the next important discussion is to find the number of zeros from graphs. the number of points of intersection of the graph on x-axis will give the number of zeros. But just to find out the number of zeros by the graph, just check where the graph of the given polynomial cuts the axis in how many points it cuts. Then the number of points of intersection of the graph will be the number of zeros of the given polynomial. The x coordinates of the points of intersection are the zeros. Now here we have an example. We are given a polynomial 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2, and the two zeros are given to us. Alpha is equal to root 2 and beta is equal to minus root 2. Now we are supposed to find out, or we are required to find out the remaining two zeros, because it is a fourth degree polynomial. It has got 4 zeros. 2 zeros are known to us, 2 zeros have to be found out. Now we are given root 2 and minus root 2 are the zeros. Then the factors of this polynomial, one factor is x minus root 2 and the other factor is x plus root 2. But the product of the two factors, that is x minus root 2 and x plus root 2, is also a factor of the given biquadratic polynomial. Okay, that means if I divide the given polynomial by x square minus 2, that is the product of this x square minus 2, I'll get the remainder as 0, and we get a quadratic polynomial 2x square minus 3x plus 1 as the quotient. So when I divide the given polynomial by x square minus 2, which is the product of the factors, which are the product of the factors which are obtained by the two given zeros, then we get the remainder 0 and the quotient as a quadratic polynomial, that is 2x square minus 3x plus 1. It means that the given polynomial is a product of x square minus 2 into 2x square minus 3x plus 1, that is the quotient. Here I have applied the algorithm of polynomials, that is dividend polynomial. Here dividend polynomial is this, is a multiplication of the divisor into the quotient plus the remainder. So that is applied here. So x square minus 2 into so much. Now this is a quadratic polynomial, this is a trinomial. We can go for factorization of this by middle term splitting method, and then separating and pairing them and taking the HCF common, we get two more factors, that is 2x minus 1 and x minus 1. From 2x minus 1 we get and x minus 1 we get two more zeros, and we have x square minus 2 is equal to 0, that means x is equal to plus minus root 2, 2x minus 1 equal to 0, that is 2x is equal to 1, x is equal to half, and x minus 1 is equal to 0, x is equal to 1, and therefore the two more zeros which were to be found out are x is equal to half and x is equal to 1. So please learn this method of finding out the required zeros when given polynomial is, when a polynomial is given to you. So be careful about the finding out the factors, and then finding out the quadratic polynomial by division method, and then we are finding out the required number of zeros.